In this video, we're going to have a look at solving simultaneous equations using the elimination method. So consider we've got two sets of equations here and we have two unknown variables. Now if we've got two sets of equations and they both contain two unknown variables, what we can do is we can use a method called elimination to remove one of these variables from the equation or from an equation and then solve the resultant equation in terms of the leftover. So consider we've got equation 1 and equation 2 here. So equation 1 is 3a plus 4b equals 6 and equation 2 is 8a minus 4b equals 5. Notice the coefficient in front of the b is 4 and this one is negative 4. Notice that if we add both of these equations together, so what we'll get is 6 plus 5 equals 4 plus minus 4b, and then we'll have 3 plus 8a. If we add the coefficients of these equations together, what we'll find is that this plus 4 and this negative 4, they're going to cancel out. So we get a 0b. On the right hand side we get an 11, and then back over on the left we have 3 plus 8, that will be 11a. So this 0b all means nothing, so we cross it out and we're left with 11a equals 11. And then finally dividing both sides by the coefficient in front of a, we get a equals 1. Now to finish this back off, since we know the value of a is 1, we can work out the value of b. So grabbing either equation 1 or equation 2, it doesn't matter. If we grab equation 1 and we say 3a plus 4b equals 6, then we say let a equal 1, because that's what we found it to be down here. We say let a equal 1. We can then substitute in our a, or 1 for a, so 3 times 1 plus 4b equals 6, and then 4b equals 6 minus 3 plus b, 4b, sorry, equals 3, and then b is going to simply equal 4 over 3. So what we find is that for this system here, we've got a equals 1, and when a equals 1, b equals 4 over 3. Now moving on to the next question. Notice we've got equation 1, 2x minus y equals 7, and then negative 2x minus 5y equals 5. What we want to do is we want to find the values of x and y. So have a look here. The coefficient in front of the 2 on this equation is 2, and the coefficient in equation 2 in front of the x is negative 2. So they are the same magnitude. In the y, it's a 1 and then a 5, and then on the right hand side it's a 7 and a 5. So what we can do is if we add both of these equations together, notice that these will cancel out. So having a go, 2 plus minus 2 x minus 1 plus 5 y equals 7 plus 5. So notice that the coefficient in front of this x is going to now be 0, so 0x minus 6y equals 7 plus 5, which is 12. Therefore, this 0x is rubbish, so we get rid of it. So we can say negative 6y equals 12, dividing both sides by 6. we find that y equals, in fact it should be -6. Dividing both sides by -6, we find that y equals -2. Now going downwards, we know what the value of y is. What about the value of x? So if we grab equation 1 again, we could use equation 2, but we'll use equation 1. We go 2x minus y equals 7. Then I'm going to say let not x, let y equal -2. And therefore 2x minus -2 equals 7. So 2x, two negatives becomes a positive. 7, then 2x, then 7 minus 2 is 5. Therefore x equals 5/2. So our solutions to this pair of equations is x and y equals 5/2 and -2. Alright, third question. 2a plus b equals 8. That's our equation 1. And then equation 2 is a minus 3b equals 11. So notice how this question is different from the previous ones. In the first question, we had a common coefficient in front of our b's. But notice in our second one we had a common coefficient in front of our x's. But notice in these ones we don't have a common coefficient. So look what happens if I add both of these equations together or subtract. So if I add them, what's going to happen is 11 plus 8 will be 19. B plus minus 3b. So 1 minus 3b plus 1 plus 2a. So adding them together, we get 3a plus -2b equals 19, or 3a minus 2b equals 19. So notice we've still got two unknowns, so this is not good. What else can we do? Let's have another go, and rather than adding, we'll subtract, and we'll see what that gives us. So subtracting, we're going to get 8 take away 11, and then we're going to get b's here. This is going to be 1 take -3. 1 take -3, and that will be 2 minus 1a. Finding the solution to these, we'll have 2 minus 1, that's a plus 4b equals 8 take 3, so that's -3. So once again, notice that we still have two unknowns, and we still have down here two unknowns. So what are we going to do? What can we do? Well, what we can do is we can change one of these equations. We can scale it such that all the coefficients, we get one coefficient that matches the equation in equation 1. So say, for example, let's look at 2a. What can we do to make this up here equal 2? What can we do? So we can say, looking at equation 2, we can say that a equals 3b minus 3b equals a minus 3b equals 11, and I want to make it such that I can get 2 in front like that. Now I can't simply add 2 there, but what I can do is I can say that there's a 1 in front, and I'll put it all in parentheses, and I'm going to multiply both sides of the equation by 2. So notice what's going to occur when I do this operation. So this 11 by 2 will become 22. This 2 by 1a, that will be 2a minus 3b times 2 is 6b. And we're going to call this equation 3. So in equation 1, we've got 2a plus b equals 8. So let's write that down. 2a plus b equals 8. And then we've got equation 3. Equation 3 is going to be 2a minus 6b equals 22. And notice I've got a common coefficient now. So the 2a and the 2a. So what I can do is if I subtract equation 3 from equation 2, I'll cancel out these a's and I'll just be left with an equation with a single unknown b. So doing that operation, we'll go 2 minus 2a plus 1 minus negative 6 equals 8 minus 22. And bringing that all down, we'll have 0a plus 1 minus negative 6b is going to be 7b because the two negatives turn into a plus. And then we're going to have 8 minus 22. So 8 minus 22 is 14. Thus, we have 7b equals 14 because the 0a cancels. And then, dividing both sides of the equation by 7, we get b equals 2. Excellent. Now, next step, because b equals 2, let's grab equation 1. And we'll substitute b into equation 1. So equation 1 equals 2a plus b equals 8. I'm going to say let b equal 2. And therefore 2a plus 2 equals 8. 2a equals 8 minus 2. And then 2a equals 6. A is therefore equal to 3. So I divide both sides by 2, 3. So the answers in this case is A and B equals 3 and 2. So, or A, B equals 3 and 2 would be the solutions to this pair of equations. So, in conclusion, what we looked at in this video was how we can use the elimination method to solve the value of the unknowns in a pair of linear equations. So in the first one, we simply added the two equations together and the coefficients of 4, so plus 4 and negative 4, cancelled each other out. The second one, the coefficients in front of the x, the 2 and the negative 2, cancelled each other out again. Then in the third one, we tried to do it, but it didn't work. So we had to scale. We had to scale an entire equation such that the coefficients were equal. In this case, the a's, coefficients in front of the a's, and we subtracted one equation from the other to solve b and a.